High Peak Courses are a British government registered learning provider with the UKRLP. Hello, I'm Warren Leigh. Welcome to High Peak Courses. This free introduction to the design and analysis of structural composites is suitable for student and graduate engineers who have little or no knowledge of engineering composite materials. So, if you're interested in composites as a career and of course the income, then let's get started on this free introduction to structural composite materials. No credit card is needed. At the end of this course, you will know the basic conventional reinforcing fibre composites, know the basic biofibre and advanced fibre composites. Be aware of the diverse application of structural composites in various industry sectors. Appreciate the merits of composite properties. Understand how fibre content influences composite performance. Understand how the manufacturing method affects an important composite property. Understand the basics of composite property tailoring. Understand the effects of fibre orientation on composite properties. Understand the influence of composite properties and component geometry on structural integrity of the composite component. An appreciation of the resource team that supports a composite project. In this Lecture 1, I introduce to you a variety of products from many sectors that are manufactured from composite materials, in particular structural composites. The first part of Lecture 1 deals with what I call conventional composites, that is, of glass fibre, carbon fibre and Kevlar, all in a resin matrix. The latter part of the lecture shows examples of more exotic composite materials, such as biocomposites, high-tech fibres like silicon carbide, natural fibres, consolidated composites such as carbon-carbon and ceramics. The main focus of these structural composite courses is on the initial design and composite component sizing. So what can you make with composites? Well, you can make £1,600 a week as a stress engineer on aircraft composite interiors. Okay, seriously, but what can you make, or should I say manufacture, using composite materials? It depends upon your engineering imagination. For example, with this carbon fibre fabric, or this glass fibre fabric, or Kevlar fabric. Mix these fabrics, these fibre fabrics, with a resin matrix, such as epoxy, vinyl ester, polyester, or phenolic, and with this we can manufacture a thermoset composite material. This is a resin infusion moulding process. With these composite materials we can make aircraft parts, such as a fuselage or wings. This Airbus A380 aircraft, for example, contains 40% of glass fibre composite in its fuselage. And this particular glass fibre composite is called glare, G-L-A-R-E. And with these composite materials, we can make an aircraft galley. Or, by taking a honeycomb phenolic and bonding to either side a glass fibre skin, we make a composite panel. This type of panel is then used to make the aircraft interior, such as a galley or a stowage unit. A similar panel is shown here. An aircraft galley is a composite structure where your onboard meals and drinks are prepared. You find these located at the rear of the aircraft and also at the front of the aircraft in some cases. If you're interested in learning how to do structural certification calculations and reports for aircraft galleys and aircraft interiors, please go to www.highpeakcourses.com. The next time that you sit in an aircraft, take the opportunity to touch the panelling around the window. This cladding material will also be glass fibre in a phenolic matrix. Now this seat on the aircraft is also made from glass fibre phenolic composite. Formula 1. Virtually all of the body and steering structure of a Formula 1 car is made of carbon fibre epoxy composite. Reduction of weight is so critical in the design of this vehicle that structural optimization software is often used. This is a composite rear wing from the Red Bull RB4. The outer skin of this wing is carbon fibre in epoxy, and it has an inner foam core. The Jaguar F-Type contains many carbon fibre parts, such as a carbon fibre bonnet. This is for weight reduction. Musical instruments such as this carbon fibre violin, and utility items such as this carbon fibre key holder. A carbon fibre frame off-road wheelchair. Designed and manufactured to raise money for charity, it was used by its owner to get to the top of Ben Nevis, which is the highest mountain in Great Britain. The Lotus all-carbon fibre bike, the first such composite bike to win a gold medal at the Olympics back in the 80s. There are many sport products made from carbon fibre materials, such as tennis rackets, fishing rods, and sport shoes. This all-composite footbridge spanning over a golf course and the River Tay at Aberfeldy. First of a kind, designed and erected by students from Dundee University in 1986. A glass fibre phenolic driver's cab panel. This is on the ABB train called the Chiltern. This train was launched in 1999. This item is the front part of the train. This is made from glass fibre using a spray-up technique. Pultruded glass fibre composites are used in rail, civil and petrochemical infrastructure. A typical glass fibre pultruded grating used for safe walking surfaces in the petrochemical industry. This glass fibre wind turbine was partly funded research by the British government, Innovate, UK. The composite wind turbine seen here was under test for over 2 years in Dover. The tubular section of the Star Chaser rocket is made from carbon fibre filament wound process. The top of the rocket carries a capsule made from composite material large enough to house a man. An option considered to reduce the weight of this microgas turbine was to replace the stainless steel outer casing with a glass fibre composite. What I have shown you so far are conventional fibre composites. There are other types of composites of a different nature. Prepregs are composite materials in which a reinforcement fibre, such as carbon fibre, is pre-impregnated with a thermoplastic or thermoset resin matrix. Grow your own composites, a biocomposite, which derive from biological renewable resources. A biocomposite such as flax, that is linen, from linseed. This is a biocomposite gearbox cover made from hemp as the fibre with a bio-resin. Tepex is a thermoplastic, which is glass fibres in a nylon matrix. High-tech fibre composites, such as silicon carbide fibres. A carbon-carbon composite consists of carbon fibres in a carbon matrix. Examples of carbon-carbon are brake disc, as used for jet aircraft. This composite has low density of only 1.5 grams per cc and high temperature capability. And rocket nozzles. There's natural fibres such as basalt. For this microgas turbine we can increase the power by using a special type of composite material known as ceramics. Lecture 2 will be released shortly. In Lecture 2, I will look at the merits of composite materials. We'll be looking at layered composites, examining the trend for composites in the markets. We'll look at properties of strength and stiffness and many other properties including failure. A brief look at manufacture and 8 other composite properties that you should consider. Also, other issues to consider. Lecture 3, this will include a definition of composites, material properties, layered composites, composite tailored properties, and the most important question from a composite fabricator, the most important question from a student engineer, 3 essential composite properties you need to know before you start your design. The influence of manufacturing method, the first step in design with 2 examples given. Lecture 4, here we'll look at the initial design and sizing of structural composite components. We will examine tailored strength, tailored stiffness, tailored weight, the composite laminate properties you will need to know before you can start a design. And I will look at 2 examples of carbon fibre properties and glass fibre properties. The most important number that tells you if your composite design will work. How you should design composites with sub-elements. And 2 examples, one is a box beam example and the other is a channel beam example. Lecture 5, Structural Composites and Issues. Issues of selecting a composite material system for your project. Which human resources do you need in your team to help support your composite project? At the end of this free course, you will be offered the opportunity to acquire a CPD, that is a Continuous Professional Development Certificate, and this will show that you've attended all the lectures in this course.